First of all, I'm so sorry I can't be there with you today for this kickoff conference for the Just Now project. I think it's an extremely exciting and timely project, looking at the various dimensions of equity and law, which are also dear to my heart and my research agenda. What I want to talk to you in the time that I have available is to provide a bit of insights on some lessons learned from the advice that we developed with the European Scientific Advisory Board on climate change on setting a science-based 2040 emission reduction target. And particularly the challenge that we had there is to how do we advise on setting ambitious national targets where we have this key challenge of balancing what is feasible with what is fair. And I hope this can contribute to an engaged discussion. First, the context. The 2021 European Climate Law sets out that the EU needs to set a 2040 target in line with the Paris Agreement. It sets out that this target needs to represent the highest possible ambition, needs to be just, socially balanced and fair. It needs to be cost effective and feasible, and it needs to be considered in the context of sustainable development. And the same law also establishes a new European Scientific Advisory Board on climate change, which is expected to provide input, or which is kind of tasked to provide scientific input and scientific advice to these considerations by the EU. So this scientific advisory board was then established. It has 15 members, which are there in their individual capacity. These members, they cover a whole range of disciplines, from economy over agronomy, climate physics, energy economics, and so on. For some in the room, you might even recognize that we even have one lawyer, Nico Schrijver, so one legal expert, also part of the scientific advisory board. So that was the group of people that was asked to provide an advice, and what we came up with in terms of our advice to inform the 2040 target is basically two documents. First, we published in January 2023 a concept for a solution for how to set climate target based on scientific evidence. And then we also published 6 months later a quantitative implementation of this concept. The reason for this staggering of reports was because the EU Commission was in parallel also doing its work, and if we would just come at the very end with our advice, it would not be able to take up any of this advice in its actual in the mechanics of its considerations of how it's designing and suggesting a forthcoming 2040 target. So let's have a look at both of these advice documents in turn. First, the concept for a solution. So the concept that we came up with is basically a framework that has 4 pillars and an overarching interpretative lens. I will go through them in turn. The first pillar of the framework to set a ambitious NDC or 2040 target is to consider the legal context. And as you will see, there is this continuous interaction between law and science in these considerations. So we need to consider the legal context. Of course, these are the EU commitments under the European climate law, the Paris Agreement, and any other relevant legal acts. The second pillar is to understand the limits to emissions of this legal context. On the one hand, these limits are physical. If we have a temperature target, there is a global limit on emissions that we can still emit, both carbon dioxide and all the other greenhouse gases. But it also already takes in or already refers to dimensions of equity and fairness, because although we can physically define a global carbon budget, if we want to split this up to an individual country or a region like the EU, there are value judgments and ethics involved. The third pillar is to assess pathways towards, in this case, climate neutrality, which is already the EU's 2050 goal, and these pathways we refer to are techno-economical pathways that the relevant communities consider to be feasible. And then the last pillar is to assess the implications of these pathways, to really understand the side effects and the co-benefits of each of the trajectories that can be considered, the resilience of these pathways in a changing climate, and also the feasibility, because we were of the opinion that if we advise for a target, we need to have good scientific evidence that we consider that target to be achievable. And then finally, the interpretative lens is that in all the interpretation and the assessment of each of these pillars, value judgments have to be made. As scientists, we are a bit wary of making those value judgments because it's not our role. But what we could do in this context is we could be guided by EU values that are already expressed in the legal context of the European climate law, of the Paris Agreement, of other foundational EU legislation, and we basically just provide a quantitative interpretation of what these values judgments would imply. And of course, all of this needs to be communicated transparently. So that is the framework, which basically means that we are balancing two approaches of analysis. On the one hand, on the left here, we look at what are feasible pathways, so techno-economically feasible reductions in emissions over the next decades. There is no explicit judgment in those feasible pathways about whether these scenario, about the emissions under this scenario, whether these are a fair representation of what the EU should be doing. They just consider what is techno-economically possible. On the right-hand side, we then have the second pillar of analysis, which is the fair share. So when we consider the fair share, however, there is no explicit consideration of whether and how the EU can respect these limits on its domestic emissions. So how do we bring these two avenues of assessment together? Well, let's have a look at this in the next slide. The first pillar we're going to look at, and now we're already coming into the second advice where we're looking at the quantification, is the assessment of what is a fair contribution of the EU to the global challenge. And there is a very broad literature on this. And here on the left-hand side, you can see some of the kind of approaches and equity principles that are engaged through the different approaches that can be drawn from the literature. Not all of these approaches are actually equitable. For example, the grandfathering approach is broadly considered to be inequitable because it would kind of suggest that past polluters are rewarded for their past pollution, which is very much against a polluter pays principle. So all of these approaches that we can find in the literature then have to be interpreted in light of EU legal norms. For example, the EU European climate law explicitly highlights that they want to follow the polluter pays principles, which is something that we can then, it's a lens through which we can interpret the approaches available. And on the right-hand side, you can then see basically remaining fair share carbon budget estimates from 2020 onwards. You can see many bars there. I'm not going to go through all of this in detail, but I think that the key takeaway message is, depending on which approach or equity principle one applies, one can still see quite a large range in fair share carbon budget estimates. Important, however, is that in some of the stricter interpretations, and these are all the bars that go downwards here from the zero line, the fair share carbon budget from 2020 onwards for the EU is less than zero, is negative. And we will come back to that in a minute to see how we combine this with the assessment of the socio-technical or techno-economical analysis. For the techno-economical analysis, we put out a call for evidence to the entire community, to the entire research community, also kind of piggybacking on the work that the Intergovernmental Panel on Climate Change did in its last assessment report and the scenario evidence it compiled there. We started with over 1,000 scenarios that were collected. But first of all, we exclude all the scenarios that did not contain sufficient data on the EU level, that were inconsistent with the other greenhouse gas objectives of the EU, therefore did not reach net zero emissions by 2050, or assumed highly implausible developments in the short term. For example, most of those scenarios start their pathway in 2020, but by 2023, the year that we published these advice, they already had an evolution that was totally inconsistent with the pathway that the EU was following at that point. So that is the first set, and then only 63 scenarios remained. We filtered then further for any scenarios that had where the described transformation would result in high feasibility concerns. So where we have concerns that what is described there is actually not consistent with evidence available from other knowledge communities in the scientific community. For example, we excluded scenarios where there is more than 20, where biomass use exceeds a certain threshold, where carbon capture and storage exceeds a certain limit, that based on the current situation is already considered very implausible. And then we also considered scenarios, or we excluded scenarios where the reduction in final energy demand was larger than what the literature suggests would be plausibly achievable. That means then in the end, we get to 36 scenarios, which we then compare relatively in terms of the environmental risks that they entail and the technological challenges that they result in. What does it mean? These are kind of the numbers, and let's focus just on the last column here, which is the actual emission reduction range from those scenarios. From all scenarios that we find and that we consider are feasible, we identify emission reduction range in 2040 of 83 to 96%. If we, however, subselect from those scenarios all the scenarios that stay within or that limit environmental risk, for example, risks to biodiversity, risks to trade-offs with food production, we get a narrower range from 88 to 95. And if we then go even further, if we look at those where we identify key challenges for the technological development in those scenarios, for example, a very quick scale up of photovoltaics, of solar power, of wind power, this range is further narrowed to 88 to 92. Now, how do we combine then the two threads of analysis that we carried out? On the one hand, we have identified that a range of 88 to 95 is feasible, techno-economically feasible, without infringing on key environmental sustainability thresholds. So that is the first part. At the same time, we noticed that the fair shares that would be assigned to the EU were all smaller than what these techno-economical pathways can achieve. And that kind of suggests that irrespective of what the EU does until 2040, their domestic reductions alone will not represent a full package of a fair contribution to the climate change mitigation challenge. And that is why we were able to advise not a range of 88 to 95, but a range of at least 90. So that results then in our final advice being a emission reduction in 2040 of 90 to 95% relative to 1990 levels. This is the kind of the framing how it was in our advice. Important here is we highlight that this range considers multiple dimensions of fairness and feasibility of the emission reductions, but it doesn't say yet that it's fair alone, because what we highlight in our second finding is that pursuing the more ambitious end of the 2040 target range improves the fairness of the contribution, and also that domestic emission reductions need to be complemented by measures outside the EU to achieve a fair contribution to climate change mitigation. And that is really key here. So we highlight that the fairness can be increased by taking up deeper reductions in 2030, 2035, and 2040, by supporting emission reductions outside the EU, but we don't really specify exactly what the mechanisms are to pursue that. And finally, also we highlight that if even that package is not yet considered fully fair, then the EU also needs to consider the net negative emissions or the active removal of CO2 emissions after 2050. And in a way, that is already part of the EU climate law, which suggests that the achievement of the net zero target in 2050 is with an intention to get to net negative emissions thereafter. In the interest of time, I'm going to go quite quickly over this visual, but what it shows is the blue bars here show the cumulative budget implied by these targets from 2030 to 2050. The purple bars here on the right show equity quantifications of the budget that would be considered fair based on different equity interpretations, and that what you can see is that the bars, even under 90 or 95% reduction, are both higher than any of these interpretations of equity. And that kind of highlights that what is needed is ambitious pre-2050 action, mitigation outside of the EU, and then finally also post-2050 we need to have net negative emissions within the EU. In terms of pathways, it looks like this. You can see here pathways that start from the EU's current level that go through through the 20 to 55 reduction point in 2030, because the EU has at least 55% reduction target right now, go through the advised 19 to 95% reduction range and reach roughly net zero greenhouse gas emissions in 2050. This is again what I highlighted are the different ways of how this can be further improved in terms of equity and fairness. But important here, and this also links back to the previous presentation, is that even to achieve these emission reductions, different choices can be made about the path or the strategy that is pursued to generate these emission reductions in 2040 or by 2050. And here you can see with the European Scientific Advisory Board, we selected 3 pathways as iconic pathways to illustrate the different choices that can be made. One is called high renewable energy, a pathway with demand side focus, and one with mixed options. In the advice, we provide kind of small storylines to explain how those pathways are different. They all reduce emissions, as you can see here. these pathways show the emission reductions, but they do so in very different ways. I'm not going through all of these, but just to give you a flavor, this demand side focused pathways, it assumes less resource intensive lifestyle, very low final energy demand in 2040, and a very low reliance on carbon removals by 2050. Whereas if we get to the high renewable energy pathway, it has high renewable energy development, high deployment of non-biomass renewable, and the highest rate of electrification by 2040. Again, in terms of emissions, they all go down and meet the targets that we advise. For each of those pathways, however, we can look at different trade-offs and synergies with the Sustainable Development Goals. And this is a key insight. Even if we reach a certain climate target in terms of emission reductions, there are still important choices to be made about how these emission reductions are achieved. And this leads me then to the last few recommendations that I want to highlight of this advice. First of all, we highlight that achieving the recommended 2040 target requires rapid, inclusive, and well-managed transitions, referring also to the just transition considerations that were important. But these are important to address environmental risks and technological scale-up challenges. But importantly as well, as I highlighted with my last visuals there are different pathways to achieve climate neutrality, and decisive choices between various policy options therefore have to be made. There are also common features between those scenarios, and they could be helpful to guide further policy developments. And with that, I'm at the end of what I would like to present. Thank you again for the opportunity, and happy to take any questions.